All right, welcome everyone to my talk of remote desktops with full 3D support. This is more my sort of adventures of trying to figure out how all this stuff works. So I learned half of this stuff writing these slides. I'm sure there's people who know more than me here, and I'm at most 90% sure of things. We'll see if I can do a demo. I'm struggling a bit with the internet connectivity here because they block UDP, so no WireGuard for me. On my mobile hotspot, and I have horrendous connectivity. So we'll see how that goes. So the background of this, I've been always annoyed at why we need something like virtual GL. First of all, it's not flawless. I mean, you can find a bunch of issues in the for various applications. LD preload, that's like a rough thing if you want to run like a flat pack or a container or something. You'd have to have it inside that environment. So that's just puts all the flat packs. If you want to run Blender, for example, from a flat pack, that's just not doable unless you do some real in-depth hacking. And I'm not sure about things like EGL as we come into the future here. Certainly when we go to Wayland, even though EGL is technically possible on X11, it is non-existent as far as I can tell. I looked for any application that does native EGL on X11, could find nothing. Vulkan actually just works anyway, because they don't rely on the window manager to get the GPU buffer. So that's nice for all of us already. Know if the desktop itself can do some 3D acceleration to do the actual rendering. That's a very secondary condition. But I can share my own laptop on a video stream or something, and I can play a video game. People do it all the time on Twitch and so on. Like, why can't I just get that as a remote desktop? I want GPU, I want it headless, I want resizing dynamically, I want a native client, and maybe also web client, great quality, low latency, and so on. It's with Wayland support as well, as that's where we're all heading, seems to be, slowly. So I'm gonna try to assume you don't know, you know even less about how the Linux graphics stack works than I did when I started this. So I'm not gonna fall into this trap here. Classic XKCD. So the Linux desktop stack is first of all, we have to refer to what's actually clients here. And it's everything. These are the clients. You're not the client of the desktop. The applications are clients of the underlying display server. So they are actually just all clients, even the menu bar up here and all the windows and every application we basically, with a graphical component that we built with EasyBuild, they are all clients of a display server. If you do X forwarding, for example, you run the display server. That's the one that does scan out to your monitor, and the remote application is the client to that server, and they send the draw commands to your server that you run locally, and you view it. So it's a bit of reverse situation, what people can be used to. Usually you imagine that your laptop, that's the client, and you're connecting to the server. No, it's the other way around. There may be some specific things in the corner here. We have some compositor-specific things, like how to switch virtual desktops and so on. And some of the tooling might require some more low-level components. But that's just often optional features. So there's like logging in or locking the screen would require the PAM stack. So the compositor composes all the applications into a final buffer. We have things like Mutter, Kevin, LabVC. I'd argue Xor itself is a simple compositor, even though in X11 terms, the compositor usually have a very specific external compositor that typically does some fancier 3D stuff. I don't know if anyone remembers good old Compis down here. I just grabbed a little screenshot. We all ran that once upon a time, if you're old enough to play around with. But that sort of displays like what a compositor could theoretically do. Nothing stopping a compositor from all doing this stuff, like having a transparent window and so on. It's not up to the application here. It's not that
file browser does itself transparent. It just sends, I'd like these pixels, please, and then the compositor composes all of that into the final picture for the screen. So shadows of things like this, that's the compositor doing that. So I think that makes sense. We also have a window manager, although this mostly is a term that was part of the X11 stuff. And that is the program that controls where all the windows and things should be placed in relation to each other. You might have something like a tiling window manager that will, as we move a new window, it will shift all the other ones around and place things nicely and compactly on the screen. Typically, this is a very lightweight program. You can maybe can even do like a scripting language for this. It doesn't run at 60 FPS even when you're playing, unless you're minimizing windows and so on. This doesn't run so frequently. So on X11, they also do some window decorations, unless you have something, if you ever heard of client-side decorations, where the application itself wants to do its own window bar of menus and so on, typically like browsers and such, wants to do that rather than having the built-in one. I think if you open like Spotify, it probably does client-side decorations. And it typically comes with themes here, so you have some window manager theme on the good old X11. These, we'll see, kind of disappeared with Wayland. It's all built into the compositor in that case. Clients then, so as mentioned, the server is the one that's doing the rendering. Everything else that does any of the X links to our, anything that we have in EasyBuild that links to our X11 package, those are the clients, all those softwares. There may be some specific parts that are X11 or Wayland specific. Various protocols only sort of have one thing, like the layer shell application that's quite popular with Qt layer shell and a GTK layer shell. Allows for having sort of a good old classic conky style window overlay and on the desktop and nice things like that. Others applications may just call X11 draw calls directly, but I would say these are rare and few and far between. Most of the things here just gets abstracted away with the widget toolkit of choice. But they're all just normal applications, and that includes all the panels and toolbars and docks and whatnot. If you might think of having some special meaning inside your desktop, you think, well, how do I get that panel thing? That seems like it's something different from running Emacs. Well, it's not. There is clients that have special hints to the window manager about, I'd like to be on top, please. And also, don't tile windows on top of me when you maximize a window. Nothing stops us from just compiling your own panel plugin and loading a module and running that in your Turbo VNC today. It's they're not special, even though they might seem. There's two that I think we've merged in for developing such things in EasyBuild already, U and QuickShell. QuickShell is nicer on Wayland, would say, but you can make some fun things in either of those two. So typically the panel might include the desktop switcher and so on, and that only makes sense on the right desktop environment. So whether or not you might use one where it makes sense to tile vertically and horizontally, whereas on other ones it's just a sequential number of displays. So that's specific implementation required for each desktop environment. The background itself is a client also. So if you have like your trash bin and the desktop background image and all of that, that's also just a client. So anything that's, if you just run Xwork without all of this, you will have a mouse pointer and a black screen. And that's technically, you're running a display at that point. It's pretty boring. So it's a pin to the bottom layer. Again, on X11, there is some real complex window hinting systems and stuff that you have to sort of rely on. It's pretty archaic, in my opinion. On Wayland, it's a bit nicer with the layer shell extension. It's a bit more clear about what goes where. Again, you can run this yourself and replace. You can kill the XFCE desktop background app and launch another one and get a different desktop. In any remote desktop solution you run today, you can probably just do that without any harm. The 3D stack then, the other tie that I want included in here. We have some OpenGL stuff that's, if you actually look at some OpenGL code, you will see something like a GL begin, triangles, GL vertex, blah, 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 if we're looking at real old classic OpenGL. Notice that we don't give it a buffer or anything, like it just draws somewhere that we haven't really thought about. I didn't tell it about my display when I called this function. How come not? Well, that's sort of like a global state, typically in programs. So you would ask the display, so you do like an XOpen display. This is like a snippet of code from GLX gears, which is a prime example of what it takes to draw a triangle here. And you will create a context. And we see here, unfortunately, we're like, oh, we're tied to the windowing system of some sort. We need to ask the display server here for the context. So we are at their mercy here when it comes to GLX to initiate the context. So that's the EGL code here is very similar, but it also has some like extensions that virtual GL uses to get a buffer without having a display. So if you use the EGL backend for virtual GL, that's the trick it uses. On X11, you can use GLX or EGL to initiate. I can't find a single example of this other than the Mesa demos. That's EGL gears _ X11 that we've all built. If you built the OpenGL package, you'll have that binary in there. Seems to work with virtual GL still, but that might just be a side effect of how it initiates the context and does buffer swapping, but I'm not sure. With Vulkan, they throw out that whole stuff. With Vulkan, you're on your own. You have to figure out what are the GPU devices, which one should I be using for my application. You get absolutely no help from the windowing system. You'll have to find the device, decide which one is the correct one to use for rendering. If you have a laptop with maybe an integrated GPU and a dedicated GPU, it's up to each application to figure that out. The benefit is that it just works, but you have to write some 300 lines of code at least just to get one triangle on screen. But I was playing around. I was not expecting this to just work on even if you start a Turbo VNC server, but it does. So DataVis is the one scientific visualization tool I found that actually uses Vulkan. So I'm working on an easy config for that, but it had a bunch of dependencies. So I didn't get that there in time, but expect that one to show up. It's pretty impressive piece of software, actually. So that one turns out to be a non-issue. So the even lower level stuff that we have to potentially deal with when we start making our own servers here is some terms that you maybe have heard of. I think we've all heard of like DRM, not the digital rights management, but the actual direct rendering manager. That's the part that supplies these devices. With combining that direct manager here, we have I think more abstraction as we go higher on this slide. So like we have a kernel mode setting, that's the lowest level of direct rendering interface of handling scan outs to the screen and stuff like this. Doesn't do any of the rendering stuff there. And then we have the actual render devices that you might use. You can find like FFmpeg will pick up on the render D128 in order to do hardware encoding. And then we have top here if you want like buffers to do actual rendering on. And this is the part where some of these tools might, like the display server itself, might connect to using GBM. So just to compare these two a bit, on X11, you run an X11 server, and there's probably more than you think. I try to find a more or less exhaustive list of things. You maybe heard of Xorg and XVNC, X virtual frame buffer, X Wayland. If you're on Wayland, you might have heard of that. Those are all implementations of the X11 protocol. But there's also a bunch more here. Some of them you maybe have heard of, but there's so many. There's a ton of them. So you might have heard of Xorg and thought that was the one. That's the X11. No, it's all of these are X11.
It used to be Xseed.
It was another one. Did I mix?
Xseed.
Okay. Well, yes. This is not exhaustive. I try my best to collect everything I could find that are like distinct. A lot of these are forks of each other and so on. And on modern desktop, we also probably run a compositor on top of that with that composite extension of X11. But you don't have to. You probably don't do that if you run like an XFC desktop on a VNC server setup. Some critical limitations here, like what hurts here is that X virtual frame buffer, X VNC has no support. They don't even pretend to support anything about GPUs. So anything that tries to do an X open display, please give me a GPU buffer, that's not happening. I think like Chasm VNC added a fork where they do some of that potentially. I didn't have time to investigate. So you rely on an interposer like Virtual GL that sort of hijacks the buffers and just secretly renders it elsewhere and gives you back the picture at the end. I tried a bit, and you can run a true Xorg with full 3D support headlessly. You kind of do it already if you use Virtual GL. You probably set one of those up. There are issues here of starting multiple ones of those. There's only one /dev NVIDIA CTL, which is something Xorg uses to interact with the GPUs. I think if you start a second one, the first one, you just kill the first one. So sharing it for multiple users then becomes difficult, which is why no one does this. Changing resolution is a pain because you basically have to fake edit numbers for your fake display and stuff like that. So dynamic arbitrary resizing is difficult. There is some stuff here with XRDP that has an extension of video driver. It doesn't support NVIDIA here, so that's most of us have NVIDIA GPUs probably, so you're screwed there. I'll skip ahead for time. Wayland here, they merged all of this. They merged Xorg, input handling, and the compositor into one program here instead, into one thing. So Wayland and X11 is just a protocol, and libwayland doesn't do any rendering or something. It's just protocol plumbing, I think. I mean, I might have some component there. So there is no Xorg equivalent here anymore. You start the compositor instead. So you start Sway or LabVC or something. That's what receives all the commands. The compositors are still opinionated, so they decide everything, whether or not they even have a virtual desktop or how windows are placed. So they do window manager as well. I missed putting that in. Yes, the window manager part is also merged into the one program itself. So it's just the one thing that does all of that now. Theoretically, they actually only wanted the Xorg in input handling and the compositor. They actually didn't want the window manager. They just came in along for the ride. So some of them are trying to work on sort of splitting that out to a standardized protocol instead to allow for custom tiling compositors into any compositor. They have a lot of protocols extensions, and basically none of them ever get standardized. So there is a link here. You can search. You can find it online if you search for Wayland protocol table or something. It's a massive list, and everyone, it's all unstable for everyone, and all of them make their own extensions, more or less, unfortunately. So one thing here is that you can just nest, you can start another sway inside your current desktop here if you have it installed. You get a window with another desktop environment inside it. That's interesting when it comes to sharing with VNC, because we can have the one that supports VNC and then run anything inside that afterwards. So remote desktop then on X11, we typically just run, it was built into that display server typically. We typically run like XVNC type things or various forks of it. So it's what's sort of built in. Instead of doing scan out to display, we just send it off in a buffer. We have XRDP for RDP support. Again, that was a separate compositor, then that got sort of merged into Xorg itself. So it's just a custom video driver at this point inside Xorg. But again, that's sort of the protocol is built into the compositor in those places. It's also very easy just to, they didn't have that type of security on the X11 days, so you can, any program can just see the entire screen and all that stuff. And they tightened that up for Wayland, which means that you can't just write a program to get to see the entire display. You have to have some protocol to fetch the screen information. But that's why it was easy for things like Zoom, Steam, and things like that to just capture the display and just send it off to somewhere. Like if you use Zoom, you can very easily share screen. It's more severely limited in Wayland, unless you run some fairly recent protocol extensions. On Wayland here, your options today is a few things. We have the VLR protocols that was made from the VL Roots developer, who also made VNC in order to support this. And it's essentially just being able to grab a screen capture of the current screen and send mouse events and do resizing and a few other things. There is also this, you might have come, the XDD desktop portal that allows for screen capturing. That's what sort of things like Zoom and stuff runs on. So if you want to share the screen and you run Sway for tiling window manager, you have to also run the Sway-specific implementation of the XDD desktop portal application. So there is, if you do a YUM search for that, you will find there is one for Mutter, there is one for Kwin, there is one for VL Roots-based managers. So we always, in Wayland situation, we always just start the compositor by itself, and then we do screen capture off of that. So it's the same path. It's not a separate path from screen sharing versus starting a headless desktop over VN. So there's no XVNC anymore. So X-Wayland is a full X11 server as well, similar to Xorg and XVNC. So we can run any such old GLX type application. If we have a working Wayland, it should basically just render normally without any LD preload hacks. You can still run virtual GL. You get your 3D buffers via the Wayland compositor if you've set it up to run specifically. But yes, headless remote desktop then. So you expect to be sharing an existing session. That's what all of them basically assume these days, like the GNOME remote desktop tool and so on. So we need to get a headless one set up here. That's the next thing. I'll jump ahead a little bit. I have 2 minute slides. In X11, we start Turbo VNC. That starts XVNC. That starts our session. We typically have a few extensions for changing desktop size that are part of the RFP protocol. But this also changes here. Sorry. You could do very similar thing with Xorg as well. You can start a true Xorg, and you can run X11 VNC to capture that display and send it out. no one does this, and also X11 VNC is unmaintained and hasn't merged a PE request for years, so I decided ditch that. XRDP is nice, still no VNC, it's still no support for NVIDIA drivers, so that's bad. But we run it currently. So you could have a headless Xorgs situation here, but that's boring. Let's go to the Wayland situation. So I'm sort of jumping over to the next part of the technology rather than spending time on the Xorg stuff. So WaveVNC compositor can work with anything based on VL roots, so Sway, River, Wayfire, LabVC, and a few others. Again, just like the Xorg situation, we need to convince it to run headlessly somehow, and then I attach our remote desktop solution to that buffer. So that's how you do it. Sorry, it's small, but you'll have the slides later. We have a few modules already merged in EasyBuild, so you can load our LabVC. I think that's merged in XFCE, and WaveVNC is maybe a draft PR because I need some experimental features of it. The rest of it is like convincing it to use a hardware device if there is one, or a software rendering if there's not, and then launching it. So dbus run session, I run it together with just starting the XFCE session inside that, and the XFCE model we build has full support for Wayland. And then you attach and make a WaveVNC listens to a port. And then you can just connect to it. So it's basically, you could run them separately. You can start Sway separately, and then you can just set the Wayland display variable to say, I'd like to listen to that one. And then just have a WaveVNC expose that over VNC. So it's a pretty simple setup when we come down to it. We just start the compositor headlessly, and then just attach a VNC to it. There are some things to think about if you want to run it for real, but that's for you to read up on your free time. XRDP can also support grabbing from WaveVNC. Again, some details here. Whatever KDE and GNOME is doing, I don't know. GNOME just doesn't want you to let you start anything headlessly. It needs systemd, login. It loves that stuff. Just to throw it out there, there are some other tools one could look into in the future, like Selkies. I did an experiment with that to get the desktop over WebRTC, which is basically the same thing used in a lot of chatting protocols here of like Microsoft Teams and stuff uses that. So I actually got it to work, but it's doesn't support resizing and stuff like that. But again, we can pick pretty freely of how to expose this interface, because part of the problem of launching the headless desktop is separated. You do that, it exists somewhere, you can't see it, but then you just need to attach something to view it somewhere else. There are a lot of this is like work in progress, very early days still for a lot of things. Nesting the compositors, that's the approach that the ThinLink developers are going for with their V0 VNC server. It's recently developed a few months ago. We have a few steps to build all of this with EasyBuild. In fact, most of it is merged. You can build the stuff that's been merged already, and it will work to run that little demo setup I had before. I'm not too keen on building KDE and GNOME. It's just pain. But XFCE wasn't too bad. But those are, you have Sway and LabVC, those are pretty, very easy, surprisingly easy to build. Actually, it's barely anything. We already built most of the stuff we need with X11 bundles and stuff like that. So it's a bit early days. But this does just work. I have it running already even for our users in our open on-demand portal. So they can get either with no VNC or a guacamole-based RDP solution. Capturing screens is not as easy as it was on the X11, but the XCD desktop portal or these custom extensions that they make is actually not difficult at all. They just can't agree on standardizing any of those protocols for years. That's been the only issue, really. Sometimes the compositors really hard code assume that no, of course there will be a display. What are you talking about? You have a monitor, you always have to. So you need to poke it a bit to convince it to run headlessly. Fortunately, it's not too bad with VL roots, so that's why we focus on those here. GNOME is just difficult to even start at all, a second session. If you want to run it as part of jobs, they don't like that. Some interesting discussions that one can follow up and read into some of the details there of both the Tiger VNC and Turbo VNC developers. See where they're heading. I thought I had a slide for a demo slide here, but let's see what it looks like here if I still try to launch a few jobs earlier. So I have a VNC-based and a RDP-based solution running. The modules that we have installed, I already pre-launched it here, so oops. I have horrendous connectivity here. See, I can't just even move in. It's not the desktop's fault, it's my connectivity currently. It's really bad, but I can just run any of the EGL applications just natively. I mean, if I just do GLX info or the GLX EGL info, I can see that it finds my NVIDIA GPU here in this case without any tricks. I have some demos here, but I think they run nicer under the guacamole ones. I will just run it here instead. So first of all, Vulkan. So this is DataVis that does 20 million point clouds of points here in this render. Let's see if, and any lag I have here is just because of the drawing the image and sending it over the network. Locally, this is pretty smooth. Well, okay, so you can see it's smooth. It's somewhat smooth considering it's a lot of points here. Let's see if I can try to zoom a little bit. Yeah, we can see the density of the points in this scan. That also just works everywhere. That's the nice thing about Vulkan. You don't have to deal with any of this stuff. I also had like just Flatpak run org blender. I need to spell correctly. Oh no, I only had that on the login node. I didn't install. I just threw in a Flatpak to stress something out. Let's see if this one loads. Okay, why? Actually, might need. I think I only installed it on the one of the login nodes. Oh, actually, no. I have it as a container as well that I installed. So this was my best attempt at doing something really heavy and complicated. Actually, I think it gets tricked by me setting something. No. Okay, well. Well, oops, I didn't mean to run with EGL run. I meant to run it without. This is, I'm just gonna connect with Tiger VNC instead. And here we see one of the shortcomings where it's early days. XFCE desktop doesn't understand resizing the windows. It looks like it was broken, but it's just that one not supporting it. Let's run. I took the heaviest demo I could find. It's just drawing the screen that's slow on my poor mobile phone. Well, it's a lot of, this doesn't even load if you don't have hardware rendering. Wow, it's even slower now than when I was testing it earlier. Well, it's a pretty advanced, this is live rendering as well. Normally I would be able to rotate and zoom and all that stuff, but it's, my poor phone is struggling. Yes?
Yeah, maybe we.
Yeah, it's open for questions. Any questions? Have to get you to sit closer.
Next time. I am very impressed about what you have demonstrated. So just to summarize all of the demonstrations you have done, you were using your mobile phone to connect to your cluster back in wherever it is.
Yeah.
And I really have to say, well done. I am absolutely speechless. So no question, compliment.
Okay, thank you.
Yeah, very impressive work. I was wondering, did you ever try running this on an Aptena container or something similar? Did you have any challenges there?
Right, so we discussed this. I see no reason why it wouldn't work inside an container. There's no, it should work all the same. I don't see why not. I need some pretty cutting edge versions of things. So you need to run one where you can install a new enough version of VBNC and XFC and all that stuff, because it's really only very recently this has been possible. I don't foresee a problem. The reason why we discussed it earlier, the reason why I avoid it is running a desktop through a container also makes, unless you do some more advanced sub-UID mapping of all the possible groups, every file is owned by nobody. So you can't do like, when I open up my file browser and so on here, it would be less useful for the users. And I have problems with like VNC, SSH refuses to work if they're not the right owners of files and so on. So running a desktop through Aptena is painful for that reason.
Okay, cool.
And also you need a nice and fast file system to run this. Over my NFS here, you notice the lag when opening up, because all of this is from EasyBuild installed, even the terminal and everything in the desktop environment and the panels via EasyBuild now.
Why are you punishing yourself like this?
Sorry?
Why are you punishing yourself like this?
Well, I want this myself. It's me and a colleague who have more of an interest, curiosity about this, and I'm thinking, why wouldn't this work? And Wayland is coming, whether you like it or not. Now it's going to be a long, slow death for X11, especially on HPC. Well, at least it was nice to know that Vulkan isn't going to be a problem for anyone, regardless of your solution.
I mean, for us in Easy, this is phenomenally interesting, right? Because I mean, if we can ship what you've done in Easy and you can connect that to Open On Demand, then anyone can have this set up independently of whatever you do, right? Because this is all independent of what you're actually doing with inside the machine itself.
Yeah, so there are the biggest challenges is actually like the authentication flows and stuff like that, and getting a nice desktop client that supports things. For example, WaveVNC only supports the newer resizing protocol, which is an asynchronous call. So if you open it with like Remina or something, it sends the old version of the resize command, so it won't resize. And no client on Windows that you can get at all sends the resize command. None of them. So that's why we've gone through quite an effort of going the RDP route. Unfortunately, the only RDP in the browser is made by Devolutions. Maybe some of you have heard of them. Or something. It's a remote desktop solution as well. But they refuse to fix bugs in their rendering protocol, so all the pixels are scrambled. So it's still a mixed and painful things to get things running. But the VNC one with no VNC, it should just be able to run.
So why is some of this stuff so cutting edge? Because it's not exactly new to 3D render things. Is it because new things have popped up like Wayland and it's still being developed?
So if you wanted to go the Xorg route with X11 VNC, which you could do, then this isn't cutting edge. You can run some old stuff.
But that's a dead end.
Yeah, building Xorg turned out to be pointless, in my opinion, because you need the NVIDIA drivers anyway, and unless you're ripping apart the RPMs, you're installing Xorg as a dependency for those RPMs anyway. So I had a go at building Xorg. We are almost building Xorg already. XVFP it's almost that one, identical with a few different changes. But even like the software rendering, you have to hack so much. So I decided to skip all that, go with Wayland, and like XFC, you need the latest version of XFC support Wayland. They only added it so very recently.
And that has been an effort of what, the last 5 years, or?
I don't know. They've been slow, and they're also now developing their own compositor. They don't want to stick to LabVC. They want to make their own that basically replaces what used to be the XFC for windowing. Something that's gonna be a Wayland compositor instead that does the window management. I don't know why they need it. I think they can. It works with LabVC.
They're having fun, I guess. Like you're having fun with figuring all of this out.
Yeah, but there's too many compositors. That slide of all of them is insane. I can open up that while someone asks a question.
Do we have any other questions before we go into lunch break?
These are the standardized things that have been stable of the extensions, and then we have the rest of the experimental and unstable extensions that everyone is adding. And here you have the different compositors we have so far for Wayland. And everyone makes their own. So you can see it's not a lot of green. Yes.
Fun, yeah.
Okay. Thanks.
Great, thank you.
I can write a new one and put some more extensions.
Yeah, you want to add the XFC people are planning to add another column here. That's their plan. I don't see a reason why, but there is some Rust frameworks that people use that they give them a pretty beefy start on developing their own compositor. I forget the name of it right now, top of my head, but that's what a lot of these build upon. So they're not like clean slate implementations. All right.
Okay.
Super.
Thanks a lot.
How do I get
Okay,
this
we
up?
have